today we're going to look at one case study, Jig design, right? So the first one, case study, Jig Fixture. Okay. Secondly, if we have enough time, I will go through level modeling. Okay, so right before that, I want you to go to content. All right, go to content, and I want you to download this Jig case study. Yes, we're going to have one for last week. I plan to have a makeup session on Monday or on Friday. Or on Thursday. However, I checked the schedule. There's lots of students have conflict, so I think probably will be better for me to make a survey to see which day will be better for us to make the to make up the lab, right? So you will see a survey. Okay, so today we're going to do a survey today, and then we will be able to determine which day we're going to make. All right, so taken. Also, can you send me the project already taken for project 2? We haven't picked one yet, and not sure which one are claimed already. Okay, you're talking about I think you're talking about this one, right? Jace, are you talking about this one? I didn't receive yours. I respond to all emails. I already respond to all emails. I haven't get I haven't get yours. Okay. I will check. Okay, I will check. But I believe I respond to all the email requesting the project. All right. So let me see here. Excel. Also Gawanda, right? I think I already sent the email about you. You get box Jig. That's my record. You and Nuge, random. Right? Check your email, okay? Check your email address. I believe I sent the email already. Okay. Don't know. I will check. Okay. I have a record. If I have a record, then you're good to go. All right. All right. Okay. So, most of the most of the project haven't been filled yet. So everyone send email to me and let me know which one you would like. Okay, so as soon as possible. I only get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11 been. Okay, I'm not going to do it right now, right? I'm on class, right? So I will respond to you, okay, later. Okay, after class. All right. Okay, so any other question? Okay, so let's focus on the case study first. You want to download the Jig case study and unzip it. There are some STP files. Okay, there are some STP files. You can open it directly. I will do that later. Okay, I will do that later after finish this one. I can see there are some students not still here yet. Okay. I will check attendance later. Okay. All right. So, you can see this part. Can you see this part? Everyone? Let me open this part first. Okay. Let me open part. Here's a part. Okay. Here's a part. That's a case study. Here's a part, right? Okay. This part is a flange. Okay. This is flange, and there are 4 holes. There are 4 holes being drilled. Okay, 4 holes being drilled, and this hole requires its dimension very precisely, and also its position, identity, right? The position need to be 40 evenly distributed around here, and also its location, the center line of the location is required. Okay, and 90 degrees away, 90 degrees between each of this hole. Okay, from this line to this line. Let me put it here. So if say if you look at the Flange. Okay, so which is this one, right? Which is this one. So product details. Okay, you can see here. All right. So the location of this of those holes is this center line circle, center mark is 2 3/8 in diameter, and there's 90 degrees away. Okay, is that clear? That's a requirement, and also the hole is perpendicular to this flange surface. Okay, flange surface, right? Okay, I downloaded this part. From McMaster, and suppose you're in manufacturing or in machine shop, right? So you want to produce like 1,000. Yeah. The attendance will be later. Okay, I will check attendance later. All right. Okay. So that means you need to use some. If you just produce one piece, then you can do manually. All right, you can do it manually. and make a measurement. However, if you are going to do 1,000 or even more, right, pieces, then you would like to save your time by using fixture or jigs. Okay, and then today I'm going to say if this is the final step, you've completed everything. The final step is to create this 4 holes. Okay, then what type of fixture and jig you can use to increase your production, right? So the blank will be like this, right? Okay, you're going to receive a part already machined, and the last step, the holes. Okay, the holes need to be drilled. Okay, need to be drilled, right? Then what do you do? Okay, then you can put in your benchmark and then make scratches on it and find the central holes and then drill it, right? Use the central hole and drill it manually. But the production rate is slow. Okay, it's good for 1 or 2 pieces, right? However, you want to increase your production rate. Then what we can do is we can make some thing like this. Okay, like this. So then a drill. This drill is let me see. This drill is one. I made measurement around, okay, around 16 millimeters. Okay, around 16 millimeters. All right. So what you can do here, you can find the drills. Okay, you can find, say, drill bit. Oh, sorry. Drill bit. So say 1569, right, millimeter. All right. So I'm going to use this one. To represent, right? To represent. Okay, you can find some. Unfortunately, I don't have the. This one don't have. So 16 is too much, right? So unfortunately, it seems we don't have we'll not be able to find the. Okay, we don't have the SolidWorks file be able to download, right? So what I can do here, I'm going to add one part to represent, right? So let me see. I'm going to say add a new part. Okay, new part. So, okay, add a new part, and then this part, right? This part is, say, I'm going to add this component and say this is the one. I'm going to let me see if I can do it right, just like this, right? So no. Okay, and then okay, then not sketch plan, offset, say millimeter. Okay, I'm going to use this one to represent my drill bit, right? So do that, and then open it. All right, save it. Save as. Instead of inside the assembly, I want to make it independent. Right, I should be able to find it in my okay, so part 16. Save as. Okay. All right. Now you can see, right? So I'm going to make this one. Edit. Make the flow, right? So, and made it. Concentric. Okay. Right. So you can see. Here's this one. I'm going to make this one. Make this one. Make this one fixed. All right. You can see I can use, once I put my part here, then I can use this one to drill it easily, right? So my drill bits will not move. And once I make this hole, then I can turn it. I can take this out. I can take this this pin. I can take out this pin. Oh, sorry. And take out this pin, right? Take out this pin and then rotate this part. Make this hole, right? I move this hole to here and then pin it again, and then draw it, right? And do this for the rest of the hole, right? Yeah. Pardon me? Any question? Any questions so far? What do you MVM? What do you mean MVM? Sorry. Oh, okay. Yeah. So yes, you're right. You're right. So you can see this is blank, right? This is blank. Okay, this is blank, right? So with this blank, complete blank, then you don't need to put this pin, right? It can be anywhere, okay? It can be anywhere, right? So you just need to, so I'm going to hide this one, okay? Hide this one, this is blank, right? This is blank. And then you just drill it, right? Drill a hole. And then you get one hole, right? Get one hole. Once you get one hole, then you rotate it to here. And if you look at this section view, say here, okay, right. Okay, you can, if you look at this section view, then you can see there's a hole here, okay? And also there's a hole here. This hole is bigger than the hole you would like to drill, right? And this one is this hole will be very close to the drill bit size, okay? But it's not exact. A little bit greater than this one, right? Depends on the tolerance. All right. So, and then what you can do here, then first the hole being made, then you turn it here, and then this pin will have exact interferes fit, okay, interfered fit. So it will locate this hole, and then you will be able to make the second hole, make sure this position, the position is located in the diameter of, let me see, 2 3/3, right? 2 3/3, yes, 2 3/3, and the angle between this hole and this hole will be 90 degrees. Is that clear? Is that clear? Is that clear? Okay, and then when you want to take this part out, right? Once you've done this one, then the final result will be looks like this, right? Looks like this. So let me hide the blank. Once you've done this one, once you get this done, then you need to take this out, right? You need to take this out, and then move it to the loosen this one, right? Loosen this one, this nut, and then move this one part. Okay, let me see if I can. So yeah, this jig 2. You want to make this jig 2 to the other side, then you can take this out. Okay, take this out, right? Okay, this is the whole design process. Okay, that's how it works. Okay, does anybody see any problem here? Does anybody see any problem here? The question: does anybody see any problem about this system? Does anybody see any problem about this system? Does anybody know? Can tell me what's the problem with this system? Does it have something to do with the drill? What's the problem with the drill? Any problem? Open, right? It's open, okay? It's open discussion, right? So any problem, okay? Anything you can think about it. There's a very big one. Okay, then how about Jordan? How about Jordan? I leave something which probably will not allow you to work properly, right? So drill bit need pushing. Okay, drill bit needs pushing. Could be. It's difficult. It's hard to get piece in there with that top blocked in. This one can be moved, right? This one can be moved. We can turn it on this side, right? Dennis, right? Are you talking about this one being dot? This one is blocked, right? This blocks the pieces, right? Okay, then I can turn this one to the other side, right? So for example, let me see if I can do it here, because I introduced this one as assembly, right? So then it looks difficult, but I will try. Let me see. Okay, so this one and Giga 2, right? Giga 2, and this one, right? And Giga 2. Okay, I want to say this is perpendicular, right? Uh-oh. Yeah, I think I'm not be able to do so, because this is in another assembly, right? So yeah, never mind. So this one can be moved to here. Okay, what I can show you here, section view. So in this direction, okay. So this one. Uh-oh. Yeah, you can see this is a moving part, right? This part can be moved. Okay, can be moved. It's just there's a cylinder here, right? There's a cylinder here. This is being clamped here to put it here. All right. So you got it. Okay. How to center the flange to the Geek? You can see here. Here's a cylinder, right? Here's a cylinder. I have a cylinder here. Okay. So this center line will be it will be centered by this cylinder and the hole. Right? You got it? Okay. Any other question? Any other? Can anybody think of any other problem? That's a job, right? Anyone? Okay, so if I'm going to drill it, do you think I have enough force to hold this part? This one might difficult to get out. Well, we can put something here, right? We can put some at the bottom to push it out, or that's good. It is a problem. Yes, it is a problem. So what we can do here, we have a pin here, right? Pin is here. We can put some here and put, okay, and stick into it and push it back, right? Put it back. Can we solve this problem? Or we can have threads here and then get threads and then take it out, right? The pin, this pin. Is that okay, Ram? It's not a very big issue. Yeah, it is the issue. Yeah, it is the issue. And also, you can see we put some chamfer here. So we can use some devices pushing in here, right? Push it in here and then take it out, right? To move it. So, yeah. Good question, though. Anything else? Okay, so my question here is, right? So if I'm going to push it here, do you think that the force, right? There must be a force. There must be a force, maybe rotational, right? There's a force exerted on this flange. Will this flange move in any degree? Do you see any force to prevent this flange move? Do you see any flange? Do you see any force? No, there's no force to prevent this flange to move, right? At least it can move up and down, right? Right? Although they have difficulty to move in circular direction, okay? Right? Cannot move in this direction, but still can move up and down, right? At least. Correct? So we don't have any clamp force, correct? There's no device provide any clamp force for this flange. You understand? Is that issue? Is that the issue? Do you think that's the issue? It is, right? It is, okay? So I'm going to leave, okay? I'm going to leave this one. I'm going to leave this one. You think about how to solve this problem, okay? To apply a clamping force, okay? Apply a clamping force. So to prevent the part move, okay? To prevent the part move, okay? In any direction, okay? Clamping force, okay? That's your job, all right? Other than that, although there are some small issue, it is not very huge. Okay, so how do I prevent? How do I make sure? How do I make sure this hole is this hole? How do I make sure this hole is always here, not on other position? Anybody tell me? Anybody tell me? This one, right? Okay, this one, right? This one is called stopper, right? Stopper. So when this one rotates and against this one, then this one will be located, okay? Will be located. I only use 1 point, okay? I only use 1 point to locate it. Actually, the longer distance away from this pin, the better you will the precise the location is. Okay, so however, I also need to make sure this one is not close to this flange too much, so I can take it out easily, right? So you need to, okay, you need to pay attention to this too, right? Right. Another thing we can improve is, right, as who said that we don't have said that cushions, yes, right? We can put cushions here, okay? We can use this one as cushion itself. We can use this as cushion itself. However, because if you have a lot of need to be done, then the bushing may be worn out, right? Then you need to replace it, right? Okay, yes. So you can make this hole even bigger and put bushing in it. Okay, that will be even better for higher high volume production. Okay, sounds good. Any questions so far? Any questions so far? Yes. Okay. Okay. So what I'm going to do, you understand the mechanism, right? You understand the mechanism, and then I'm going to two options, right? Two options. So you can ask me question about your project, or let me demonstrate how can we make this model, right? Make this assembly starting from this part. So let me. Okay, so A. For project 2. Demo. Create. Okay, so everyone, please take a poll. Okay. 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 All right. So, everyone, please take a poll. Everyone, please take a poll. Okay. Everyone, please take poll. I still need like seven students. We want both. We want both. Okay. How about this? Let me do B first, right? And then you can save your problem. You can either send an email to me. Or save your problem, and I will answer your question next time. How's that? If that works? All right. Okay. So then, yeah. Okay. So I will do the demo. Okay. Demo. And you can send the email to me for the questions. Or we can discuss the okay, let me see how many are those quick questions. 7, right? We get 7 so far. Okay. Okay. We take about 10 minutes to see what the problem is, and then we can do that, right? Okay. All right. Who's going to ask a question first? Who asks a question first? Let me take 10 minutes to answer question to see what's going on, right? Okay. And then we get 1 hour to do demonstration, and it will be recorded, right? So. Okay, so content. So, all right. Announcement. So questions. Any questions?
Good morning, Professor. Good morning, class.
Yeah. Go ahead. What's your
Sir,
question?
for this project, due to the fact that did not have class last week, would like you to elaborate on project 2, what is expected, and what it really entails. Because I just see the announcement, I don't fully know what is going on, so I need some clarity pertaining to project 2.
Yeah, project 2. Yeah, that's so okay. That's a very general question, right? Okay. Expectation, right?
In other words, just to make it concise.
Yeah,
What should we do and what you're looking for?
Yes. I give you example, right? For example, this one, right? For example, this one, there's an angle jig, plate jig, right? So if you look at here, if you look at this this production process, right? You need to cut 50 cut this stock into pieces, right? Secondly, you need to drill 2 holes. Can you see that? Can you see that? Everyone? Okay, so okay, so you can see, right? For cutting, then they drilled 2 holes. Okay, drill these 2 holes, right? 2 holes, and then secondly, you're going to mill the flat, right? 2 places. Okay, deburr, right? Functional gouge and cutters, solid, okay, and drill, and so on. Okay, this is the tools needed, right? So you can see. So what are you expected to? Which one do you expecting to use? In which process you need to use jig or fixture? I think this one is a jig, right? So angle plate jig, right? Which one? Edim? Based on your knowledge, right?
Yes, sir. Repeat the question.
What do you expecting to use angle plate jig in your in those process? 1, 2, 3, 4. Which one? In which process do you think you need to use angle plate jig? Anyone, right? Everyone. This is open to everyone, not just for Edim, right? Right?
The flat surface.
Do you agree? Someone says 3, right? Someone says 3. Someone says.
Yes. Would say 3.
You say 3. Okay, you say 3. Why is 3? My question,
going to need support. Yeah, I'm going to need this support at the side.
Huh?
If I'm drilling, I would use a locator to hold it in place.
Okay.
Milling, I would use the angle plate at the side.
Okay, so you mean you want to make sure this one, this hole is perpendicular to its flat surface. Is that what you mean?
Yes.
I think that's what you mean, right? All right. Okay. So in this case, you would like to make sure, because this surface will be milled, right? Will be milled. Correct. So you cannot use. Pardon me.
I said correct.
Okay. Okay. So that means you cannot use this hole. You cannot use this hole for your positioning. Correct? You cannot use this hole for your positioning. Correct?
Yeah.
Okay, so what you can do here is then you want to use this hole for positioning. So make sure this hole is perpendicular to this surface, right? Am I right? This hole,
Yes, you are.
make this hole perpendicular to this surface. So that means you have a positioning reference which is with the angle with a 90 degree to your machining direction. All right. So yes, Ram, you're right. So this is a reference. So what you're going to do, you're going to use this one to make probably a pin, probably something else to make sure this one is perpendicular to your, or say parallel. This one is parallel to your mill axis. Okay, right. So then you're going to design a angle plate jig to complete. This is the first step. You want to understand in which step you are going to apply your designed jig, right? That's the first thing. And then after that, then you're going to make a blank, right? You're going to make a blank. This is your part, right? This is your part, correct? This is your part. And you're going to tell me before this being made, okay? Before this step, what's the plan? What's the blank? What's the blank looks like? Do you know what I mean?
A round stock?
I don't think so. You already completed this one, right? You already completed this one, right? Before step 3, right?
Okay.
So what it will looks like? So then you need to let me know. Okay, first. Understand in which step you need to design your jig or fixture, right? By looking at the project and out. Okay, that's the first thing, right? Second, need to determine the blank. Determine the blank of your. Determine the blank. Okay, right? That's the first thing, right? So in this case, it will be looks like this, right? It will be looks like. Oh, sorry. It will be looks like. Right? You already have the length, correct? And you already drilled the 2 hole. Make sense? Is that clear? Then you need to. You need to make this blank, right? You need to make this blank. So first you are going to create this part, right? You need to create this part based on the dimension, and then you need to create this blank. All right. Yeah, I will explain the rubricate. Okay, I will explain the rubricate. Yeah. Okay. So what's next? So With the blank, you're going to develop the jig or fixture system, right? Okay, that's a big part. Okay, right? What else do you need to make drawings, right? Make drawings, including assembly drawings and part drawings. Okay, the assembly drawing, you want to show its position, assembly position, and disassembly position, right? So, yeah, if you can just show one, show this in one assembly drawing, that's fine. Okay, but if you want to make it clear, you can create multiple assembly drawing to show its position and alternative positions, right? Okay, all right. Adam, are you here?
Yeah,
Any more
yes,
questions?
I am.
Yeah, any more questions? Any more questions? Okay, okay, all right. So who's next? Who's next? So that's why, right? That's why I want to use a case study to explain what's happening, right? So different kind of Jig Fixture. No, this is just a case study. I didn't. This one is different from what you have. You're going to design, right? But the whole process will be the same, right? You need to understand. You need to understand the problem. This part, right? This part you need to understand the problem and specify the problem. What you need to do, and then you define the problem parameters, right? Okay. So you find the knowns, unknowns, and you find and then use this one to to solve your problem, right? So how to achieve your unknown. For example, here, right? So you can see here, you can see here. When we look at this part, right? When we look at the part, then I need to understand what's the problem. What's the problem we're facing, right? Pardon me? Samarsh Patel? What do you mean? Where? What do you mean where? Oh, okay, sorry. Okay. Right. So in this part, right? In this part, you're going to understand what the problem is, right? So here, the final step will be drill these 4 holes. So then your problem is how to make this 4 holes. But what is the known and unknowns for your problem? Then the known is you have this part. Okay, everything here you finished, right? And then unknown is how to make this 4 holes. The unknown is 4 holes. And then you're going to have a device. Your problem, your task is to find to design a device. So to turn this blank, to this part very quickly. That's your task. Okay, once you understand this one, then you're going to build. Okay, you're going to this part you can get it from dimensions from here. Okay, and then you can make a model. Okay, this part model, right? Once you get this model, then you can going back. Okay, going back to define your blank. So in your case, then you're going to remove this flat. Okay, then it becomes something like this, right? This is the initial shape, and then this is your final shape you're going to achieve. Correct? So that's your problem, right? That's your problem, known and unknowns here. Okay, known and unknowns here. And then you're going to solve the problem. Okay, to solve the problem, then you can develop something, not necessary. This is not the only one solution, right? This is not only one solution. Okay, so you can at least this system. We discussed this one, right? We talked about this system. It works for us, right? But there are some problems. Okay, there are some problems which we discussed. Is you don't have clamping force to prevent this one move up and down, and even say there are some vibrations and so on, right? So you need to add one more, something more to hold the part, to provide clamping force. All right? Okay, then your system is complete. Once you complete your system, then you will be able to generate assembly drawing and part drawings, right? Which is this one, right? Okay, this one is the big one, right? This big one. You need to think about it, and you need to use your knowledge learned from theory part lecture. All right. Okay. All right. So is that is that clear? A little bit more clear now, or still confusing? Okay. All right. So it's 10 o'clock now. I'm going to start to do demonstration, right? So if you have any question, yeah, I will do demonstration now, right? So I'm going to do this one. You know what we're going to do, right? So at least you know what we are going to do, right? So what's our problem now, right? So we're going to use this blank, okay? And then put this in the device, okay? So then we can make this part easily, right? Turn this blank to this part easily. That's our purpose, okay? Let me close this one, right? Let me close this one. Close everything. Close it. Save all. Save. Okay. Okay, while I'm doing demonstration, you can ask me question at any time, right? So we already have the part. Okay, we already have the part. I'm going to open the part, right? So yes. Here's my part, right? Here's my part. So your will be different, right? So yours will be different. Okay, so this part, and then what is the blank? What is the blank will looks like? Then without this holes, right? Without this holes, correct? So let me see if I can suppress this hole. Uh-oh, sorry. I cannot, right? So I cannot. So what I can do here, we can extrude something, right? We can extrude something. So to present this, let me save it as, okay? Save as, okay? So you want to make sure you part blank. Okay, part blank, right? So all you need to do is try to remove this. Try to remove this hose, right? Try to remove this hose. Oh, I think okay. Just give me a second. I can get another one. I can get this. I can get the original part. So then I will be able to. Yeah. Let me try this one, right? So. Okay. Here's my original part, right? So here's my original part. Okay, so then I can say suppress this. Okay, and suppress this one, right? If you made this part by yourself, then you will be able to make it, right? So I'm going to save this part. Okay, save as. This will be my part blank. Okay, part blank. I'm going to replace it, right? Okay, so now I have my part and also have my blank, right? Okay, I have two parts, right? I have two parts. Okay, one is the initial shape and one is the final shape. And then let me make this one in assembly. I'm going to say this one. We already know our plan, right? So we are going to use this one. Put this one on the platform. Okay, on the platform, and then going to use this cylinder to create for positioning, right? For center positioning, and then we're going to create some holes, allow this angular positioning, and also allow the drill bits to go through and cut the material. All right, so that's the plan. Okay, so we're going to put this one in assembly. So I'm going to create this one. Create a new file. Okay, create a new file in assembly. Excuse me. And then put it here. This is my work part, right? This is my work part. I'm going to save this one. Okay, demo. So, week 9. Demo. Jig. Now I'm going to put it in position. So this is very important, right? So you always want to put your part in a correct position so you can start to design. And as I said, I'm going to design in assembly level. Okay. If we cannot finish this one today, then we will continue next time. All right. So let me do this. First, I want to make position. Make sure this one align with my top surface, and hit OK. You can see because this one is fixed, right? Why is the problem? Because the first part component we put in the assembly is what? Is fixed, right? I make it flow, and then I don't have any conflict. However, I want this one position up. In your case, it is not necessary always drill from this. It's not always. Sorry. It's not necessary to always drill this one from this part, from this side, right? So you can also drill it from this side. Depends. Okay, depends, right? If you would like to drill from this side, then you will have different design process. Okay, results. Okay, I'm going to just use the concept I showed you before, right? So this one, okay, flip it, save it, and then I also want to make sure it's the center line. All the center line will be aligned. Okay, so front view aligned with the front view. Okay, and the right view aligned with this one. I think it's front view, not front view. Right plane. Okay. Okay. Now you can see this one being fixed, right? Being fixed. And put this one in a group. Okay. I would like to put this one in a group. So add to a new folder. So this initial position. Initial position. Okay. And then I want to introduce insert components, which is my blank. Okay, so put it here. And then mate, right? So what we can do, this one, the top surface, and direction, hit OK. All right, and then this one, hit OK. All right, you can see this one still be able to move, right? If you turn it, it allows you to move, but it's symmetric. I'm going to leave it for now. Okay, so it's not a very big problem. If you wish, you can also fix this one, right? You can also fix this one, but for now, I'm just I just you can lock it, but I just want to leave it for now. Okay, you can do it later, because if you see this one, it's symmetric, right? The part is symmetric. Okay, this is symmetric. Okay, so if you want to turn it, it doesn't matter. Okay, it doesn't matter, right? Okay, so for the first hole, it doesn't matter, right? It doesn't matter where you are going to drill it, right? Where you're going to drill it. However, the second one, you have a reference. You can use the first hole as a reference to drill the second one, and so on. Okay, right? That's the situation. Okay, I'm going to save my part. Okay, I'm going to save this one. Okay, so initial position. I'm going to put the initial position in here again. So Okay. Now I can make this one. Invisible, right? Invisible, and I still want to show my first part. Okay, show my first part. So because this one will be my final part, and I need to use those holes to create the other features. Okay, now once I've done this one, what do I need to do? I'm going to say to create the platform, right? I'm going to create the platform which this part sits, and also have the can use this cylinder outer diameter, use this outer diameter for centering, okay? To put this one in the center, okay? So I'm going to say insert a new part, right? Insert a new part. And say I'm going to edit this part, right? Okay, I'm going to edit this part. So first steer, I would like to position, right? So make front plane aligned with front plane, right? So front plane. Okay. What's happening? Okay, sorry. Supposed to be this part, right? So let me save this part first, okay? Let me save this part first. Okay. And let me save this part. So this one will be my jig, right? Jig. Jig, sorry. I can put this, say, jig 1 or say bottom, right? Okay, so if you see here, I would like to say, so week 9. Save. Jig. Okay, I have jig. Oh, that's why. Okay, so I want to put in my. Make sure you save your part in the correct location. Okay, folder. Otherwise, you may get trouble when you upload. Right. So okay. Rebuild it. And then let's go back to my assembly, right? Go back to my assembly. Yes. Okay, you can see this one's jig bottom, right? Jig and bottom. And then I'm going to edit my components. So I'm going to make a sketch. Okay, I'm going to make a sketch. So go to sketch, and then I'm going to use the bottom, right? So we know we're going to make something. Okay, you can this time I'm not going to use a round one. I'm going to use a rectangle, right? So Uh-oh. Oh. Make a rectangle. All right, so I'm not going to give the dimension yet. We can modify it later, okay? So, and then we know we're going to make a hole, okay? We're going to make a hole which is bigger than this one, So my whole bottom, the whole, then this one will be able to put in here, right? So I'm going to, oh, sorry. Okay, so I'm going to make this one as a reference and then say offset this one, say 2, not, okay, 2 millimeter, okay, 2 millimeter, okay, 2 millimeter, which is good, right? Offset for 2 millimeter, then this hole will be big enough, right? And then I'm going to make another one, which is this one, okay, say will be exactly same as the bottom diameter, and then it's used for our dimension, right? So then I'm going to make another one, right? So, so I'm going to use this one, the center line again. So this one will be my position, will be drill bit, right? So the material will go out from here. So I will make this one a little bit larger, okay? Makes this a little bit larger. So this one will be, say 2 millimeter is a little bit too large. I'm going to make it 1 millimeter. Okay, 1 millimeter should be good enough. So half millimeter on each, 1 millimeter in each side, right? 1 millimeter in each side. It's good enough. This one is 2 millimeter. You want to make a little bit bigger because you want to take it out easily, right? So if you have a very small clearance, then because it's long, so you want to make it the gap between this part and the hole bigger, right? So, and then I'm going to make this one. So this one will be, oh, sorry. Okay, this one. This one. This one, this 3. Okay, I put 3 here. I put 3 holes here. So you can either create this 3 hole or not. For my previous one, it is only for previous one. I only have one part. I only have one, right? I only have one. So what we can do here, I still use just one. You can try to use multiple holes here, okay? Multiple holes here. Then for now, I'm good. Right? So let me see if what we can do. All right. So this is my sketch, and then I'm going to make a sketch, make it solid, right? So a feature. Okay. So this one, only this one, right? So I want to make sure it's greater than this one. I just free drag. Okay, you can define this dimension later. Okay, so or you can define it here directly. So I'm going to say 50, right? 50 will be big enough. And if you think it's too big, then you can change its value. Okay, you can change the value later. Okay, so this is the part. Okay, what's next? Then I'm going to make a hole, right? I'm going to make a hole, which is which allow us to for position, right? Which allow us to for position. So this one, so I'm going to, yep, right. So, okay, you can see we can make this hole for positioning, make this hole for drill part, and this one for the pin, right? Okay, this is a drill. Okay, so I'm going to extrude cut this hole. This hole. This hole, however, in a different. Okay, so it will be through. Oh, let me see what's happening. Okay, I get my holes, right? I get my holes. All right. Okay, which is good. Now I'm going to make this hole, right? Make this hole so I can put my part here. So I don't know. I don't want to take a measurement. So I just use it directly. Okay, so you can see here. I can see I want to make this hole at least under this cylinder, right? Under this surface, this cone shape surface. So what we can do, extrude cut again, use this one, flip direction, and then I just simply drag here. Okay, drag it here. So go to here. It says 28th, right? 28th. Then let me see. How about 25th? I would like to close to this part as possible, right? As close to this part as possible. So let me see. It seems okay. Uh-oh. What's happening? Let me. Huh? Oh, that's why. Not enough, right? Not enough. So I would like to increase a little bit. 8. 27. 26. 26. Make it 26. So my position, this hole can help us for positioning, right? And we have a big hole here to fit this part. Okay. Let me save it. Rebuild. Okay, rebuild. Okay. All right. Okay. Now we still need to add some features here, right? So there's a pin here. There's a thread here to allow us to put the jig here, and also there's a stop pin here, but we don't know where it is yet, right? So we can start to create this part and this part first. Okay, let me do this. Okay, I'm going to create this pin first. Okay, so you can see it's convenient for us to use this as a reference, right? Use the other part as a reference in our case. All right. So this is the beauty of the assembly level modeling. Okay. So let me hide this first. Okay. Let me hide this first, so we don't have extra parts. Okay. Save it. Save all. I'm going to insert a pin. Okay, insert a new component, new parts. Okay, so I'm going to say, okay. So we can isolate. Okay, isolate. So, and save as. Okay. Okay. let me save as. Okay, save as. It will be pin. I'm going to make the pin now. Position in pin 1. Okay. Save with in context. Okay, without intent reference. Okay, so save externally. Okay, and okay, so okay, now let me go back to the assembly. Where's my okay, all right. So I have this part, right? I'm going to edit this part. Okay, edit this part. What we're going to do? Simple, right? So just use this hole and extrude to create the bottom part pin, and then make an offset, right? Make an offset, then we will be able to make it. So from top, create my this, and then offset, say 2 millimeter. Okay. Exit. Control 7. And then let's say I'm going to use my section view again, right? So extrude this one, bring up. See? Okay, so this one. Okay, and then extrude. Make this one visible. So this one, give a length, say I'm going to just to give a random number, 10 millimeter. Okay, that's my pin, right? That's my pin. And then I can make some chamfer. This one. This one. And this one. Then make it 1 millimeter. Okay. And exit. Rebuild. Save it. Save all. Okay, I get my second pin being put here. All right, so then I'm going to make this part, right? I'm going to make this part. So this time I'm going to insert another one, new part, again. All right, save it, save all. This one will be, say, Jig, say 2, okay? Same as assembly, okay? Same assembly. Okay, now I have this part. I'm going to edit, right? Edit. So what I'm going to do, I'm going to, again, make a sketch, okay? So it will be shaped like this, right? So I'm going to use this surface. Use it, no, use this surface, okay? Use this surface because it will be touched here, right? It will be touched here. So I'm going to use the surface as a sketch plane, and then up. This time, we are going to make a hole like this, right? Make this hole, right? Okay, make this hole. This hole, the same size as the hole you want to drill. Okay, and then I can make another one here. Make another one here, so can help us to. Let me make a reference line first. Okay, make a reference line here. Okay. Horizontal goes through this origin and then put it here. Here. Interesting. Okay. And then I'm going to put something like this. Okay, and make this dimension equal this dimension, right? So this time, because I would do something different. Last time you can see there's an angle, right? There's an angle here. This time I'm going to make it a line. So this will be a little bit different. You can think about what is a disadvantage by using this shape and the other shape. What's the difference, right? So add relations. This one, they're equal, right? Hit OK. And I want to move this one a little bit to here. So let me put it here. Let me put it here. This one's supposed to be horizontal, right? So, and then say here, here to here. Okay. All right. I think that's it. Then Control 7. Okay. So I'm going to make this one up. Okay. Make extrude this one. So to not blank. up to surface, right? Up to this surface. Okay, so I want to make this one higher than this one, right? So let me see from here, okay? All right, it's a little bit higher, right? 15, good enough. Make sure it's not touching the surface, right? So, okay, all right. And then I would like to make the top part. Okay, so extrude. It will be, let me save it. So extrude. Show this part. Delete it. Right, so what? Clear direction. This one. Okay. I still want this one, right? Okay. So surface, starting this surface. Okay. Oh. Okay. This one. Kind of mask here. Let me do this again. Okay. Okay, that's good. And then starting from surface. Okay. Right. This is the part. So this part allow us to make the hole. Let me see. Okay. All right. So this. Okay. Save it. Yes. How is that part going to drill? It's gonna be up to drill press. Okay, I think I showed it here. Uh-oh. I think I closed it, right? So, okay, anyway. So what you can do here, you can, let me save this first. Okay, so insert this part, right? Insert component, which is the drill, right? Where did I put the drill here? Okay. Drill. All right, so this is how you can make this one, okay, right? Okay. Is that what you want? No, William? Okay. All right. So for this part, I'm going to hide it, right? So we don't need it right now. Okay. So this part, you can see this Jig 2 is positioned here. Once do we have to make the feature for the drill, etc.? Not necessarily. If you can download some tools. If not, then it's okay, right? Okay. If you can demonstrate the tools, then would be great. Not necessary. For example, this one, right? It's not a drill. Okay. The tool is a mill, right? Flat mill, right? Okay.